Thank you all for joining us today for our information session, Commercialisation Pathways in Defence. My name is Liz Cobold. I'm the Innovation Portfolio Manager for the Defence Trailblazer. It's an incredibly diverse group that we have on the line today: academics, researchers, students, innovators and veterans. Next slide, please, Charlotte. Having lived here my whole life, I would like to acknowledge that I am hosting this session from the lands of the Ngunnawal Ngambri people. Being an online session with participants from around the country, I would also like to acknowledge the traditional custodians of the various lands on which we all work today, and the Aboriginal and Torres Strait Islander people participating. I pay my respects to elders past and present and celebrate the diversity of the First Peoples and their ongoing cultures and connections to the land, air and waters. Firstly, some housekeeping. The session will be recorded and made available to participants in the next few days. Could you please also refer to the terms of participation that have been posted in the chat? We have quite a large number of people joined us today, and we're unlikely to have the time to answer any questions. We propose to respond to frequently asked questions via the website, and we'll send the link through to you all. Questions for specific speakers will be directed to them where appropriate. Please put your questions in the Q&A section. Next slide, Charlotte. The objective of the session today is to provide an introduction through our expert panel into the different ways to enter the defence industry in Australia, acknowledging the fact that not everybody wants to run their own business. And we'll run through the programs on offer to support your commercialisation journey. Our first speaker is Dr. Sanjay Mazumdar, the Director of the Defence Trailblazer. Over to you, Sanjay.
Great, thank you, Liz, and welcome everyone. It's great to see so many people from such diverse backgrounds joining us here today. Firstly, I'd like to also acknowledge the Aboriginal people who may either be joining us today and pay respects to them. I'm joining you from Kaurna land here in Adelaide. I thought I'd just start off with a little bit about me, because I think it'll help to explain some of the context in which I'll make my following comments. So I've spent over 30 years really at the pointy end of innovation. So currently, obviously, I'm the Executive Director for the Defence Trailblazer, but started my career many years ago, in fact, in the late 80s, early 90s at DST Group. Spent quite a number of years at Motorola, where I was very much at that pointy end of innovation, through to, I guess, when I was the CEO of the Data to Decision CRC, where we were involved in spinning out a number of companies. So I've always been at that pointy end of innovation, and I think some of the lessons from being at that pointy end will inform the messages that I provide today. Next slide, please, Charlotte. But what I thought I'd do is firstly give you a bit of context of what the Defence Trailblazer is all about. So the Defence Trailblazer is really there to address one of the biggest challenges we have in Australia. Now, you probably heard in the media, and you can see in that article there, that Australia is really good at research, the sort of the deep research in a number of different areas. So we bat above our weight in a number of areas across the board. And these include things like AI, where a number of our universities and institutions are world leading. Here in Adelaide, and the Australian Institute for Machine Learning is in the top 5 in the world for computer vision. One of our other partner universities, UNSW, they have some world-leading capabilities in quantum computing. So we've always, as a nation, done really well when it comes to research. But where we fall behind, and quite significantly fall behind our OECD partners, is the translation of that research into industry and ultimately into creation of companies and products and services. So that commercialisation of the research is where we have fallen down as a country. And so the federal government, the previous federal government, recognised that they needed to do something about this. And so they created the Trailblazer University program. And what they did is they set aside quite a significant amount of funding, over $370 million, to really help try and address that valley of death. So the valley of death between the lab and the field, translating that IP out of the universities, out of the labs, through industry into operations, i.e. into the field. And this was a competitive bid process, so consortias were put together to bid into this Trailblazer University program across 6 areas of priority for the nation. And these include areas like critical minerals, clean energy, medical devices, food and beverage, and defence and space. And so the Defence Trailblazer proposal, which was a collaboration between University of Adelaide, UNSW, and over 50 industry partners, was the successful bid in the defence category. And really, our remit is to address that valley of death. Next slide, please, Charlotte. Now, this is even more critical in the defence sector. So, recently, Defence conducted what's called the Defence Strategic Review to really look at what is the shape of the Defence Force required to address the threat environment in which we operate. And I've pulled out a couple of quotes there. I won't read them verbatim, but probably the main thing worth highlighting there is the focus on transitioning new and innovative technologies into the hands of the ADF, into the hands of the soldiers, sailors, and aviators in the Australian Defence Force. So that translation piece is critical in defence, and it's critical more broadly across different sectors in Australia. Next slide, please. So that leads us to what the Defence Trailblazer is all about. So as I mentioned, we're a collaboration, a partnership between defence, industry and universities. And really our focus is how do we accelerate the delivery of these sovereign capabilities, so capabilities built in Australia, to the Australian Defence Force. I won't go through the mission in detail, but probably the main thing I'd highlight there is key part of what we're trying to do is maximise the value of IP and research translation. And that's really a lot of what today is all about. Next slide, please. So what I thought I'd do in the last remaining few minutes is really share some of the lessons I've learned over that career that that 30-year career that I've had in terms of commercializing deep technology. So I thought I'd just start off with a few sort of visual memes to represent what the key lessons learned. So next slide, please, Charlotte. As I've highlighted, I've spent a lot of time focusing on that sort of bleeding edge, the sort of pointy end of innovation. I've got a couple of diagrams there of some of the products and solutions I was involved with, particularly my time at Motorola. My team, for example, developed the world's first mobile banking application in the late 1990s. And that was a banking application which was built around a smart card that we had developed at Motorola, and a dual slot phone. So a phone with one slot for the smart card and one slot for for your SIM, and that enabled you to do mobile banking. So working at the bleeding edge it has always been, lots of fun, really interesting tech, really interesting technology and work environment. But there's some real challenges working at the bleeding edge, and more importantly, at commercializing IP through bleeding edge R&D. Next slide, please. And the first challenge is what I call this metaphor here, that the second mouse gets the cheese. And what do we mean by that? Well, I think what we mean by that is it's really important to understand, is the market actually ready for the innovation that you're creating? Sometimes you can be too early. And if you're too early, like the first mouse, what happens? Well, the mousetrap gets you. If you're the second mouse, so the first mouse has proven that the market's not quite ready, and you wait your time for when the market is ready, what happens? Well, the second mouse gets the cheese. And I use that analogy to represent that mobile banking application. So with that mobile banking application, we were the first mouse. We were the first people to produce that, but the market wasn't ready. We did a major trial with Barclay Bank in the UK, but it wasn't successful because the market wasn't ready. No one wanted to do banking on a phone back in 99, 2000. No one was quite ready for it. So timing is everything with innovation. Is the market ready for your innovation? That's a really important thing to think about. Next slide, please. Now, innovation and commercializing your innovation is a roller coaster ride. There are ups and downs and loops, and things go forward, things go backwards, etc. You're going to have successes, you're going to have failures. The important thing is to learn from those failures. They're learning experiences. And so over my career, we've definitely experienced the roller coaster that is innovation. And I think that's something you've got to prepare yourself for when you are trying to commercialize, deep tech. It is going to be a roller coaster ride. Next slide, please. I think one of the key things in helping to ensure you have success is really to understand what is it that the market actually needs, and how are they actually going to use this. So is the way in which you're designing your path the right way in which it's going to be used, right? You can see that analogy there where the path is designed in a certain way, but people end up walking through that shortcut. And so had we sat down with our end users, our customers, we would have realized that this is the way the product's going to be used. So therefore we would have designed the path along the lines of that shortcut. So the point here is really sit down with your end users, your customers, your potential customers, to understand how are they going to use your innovation, because that will help you shape the innovation to make sure it's addressing the real needs that they have. People often talk about user-centered design. I mean, that's really what this is all about. So if we did user-centered design, we'd be designing the path such that it takes that shortcut to the zebra crossing. Next slide, please. So we sort of took a lot of those lessons when we set up the Data to Decisions CRC. So this was a cooperative research centre that was focused on advanced AI technologies for the national security community, so defence, law enforcement, and the intelligence community. And we ended up through this CRC doing R&D in a number of different projects, and those projects are listed there: POSSL, Beat the News, Integrated Law Enforcement, and a legal and policy element to it. Those projects were actually shaped by the end users. So they were shaped by working with the intelligence agencies, the law enforcement agencies, and the policing agency and defence agencies, and that shaped what the projects were going to be. We work closely with those end user agencies to really ensure that they got early access to the technologies we're developing. They then were able to play around with those technologies. They then gave us feedback to say, well, actually, this doesn't quite meet our high priority need. We need it to do this. We need it to focus on this particular need, etc. So that whole co-creation approach was absolutely critical in helping us to build products that ultimately met the market needs. And we ended up creating two major products that sort of informed the two spin-out companies, Inquiry and Fivecast. And just by way of background, Fivecast is now about 130 people. It operates in at least three countries now, so Australia, the US, and the UK. It just closed a $30 million venture capital raise, a Series A raise, and is hugely successful. Inquiry is about 20 people, operates predominantly here in Australia with law enforcement agencies in Australia. Both of those companies have benefited from this whole co-creation approach that we adopted, and taking on board some of those lessons learned from those other solution from the experiences that I've had over time. So I might just pause there. I think you'll probably hear through the other speakers some really similar messages. But if I can leave you with one key message, it is there is huge value in co-creating solutions with people who will ultimately be your customers. And what we can do in the Defence Trailblazer is really help connect researchers, help connect innovators, help connect companies that are involved in the Trailblazer through to defence end users who will ultimately be those customers for your products and solutions. Thank you.
Thank you, Sanjay. Our next speaker is Mark Ramsey. Mark is the Chief Operating Officer for Australian startup Space Machines Company, which is Australia's only in-space transportation and logistics company. A space industry professional with nearly 20 years' experience in a diverse range of technical and leadership roles. Mark is also the Deputy Chair and a Director with the Space Industry Association of Australia. Welcome, Mark.
Thank you very much. Wonderful to be here today, and thank you for Defence Trailblazer for hosting this event and conversation. If we can jump to the first slide, just a bit of a way of background of me. I'm an engineer by background and have spent most of my time in I guess defence and space, both here in Australia and in Europe and globally. And I like to describe my role as a Chief Operating Officer for a startup of anywhere between emptying the bins and shaking the hands of the president, and everything in between. Just a quick insight into what Space Machines is doing. We are very focused on in-space transport and services at the moment. Space infrastructure is ubiquitous in our lives at the moment. We rely on GPS, we rely on communications, we rely on weather, satellites. But the current model of space infrastructure is kind of launch and set and forget. And what we've seen in the last few months is a number of high-profile spacecraft failures, hundreds of millions of dollars of infrastructure going up and not working. So sort of writing off that. We've seen some local failures. The sort of precise positioning signals went down in Australia recently. A lot of tractors couldn't do what they needed to do in the field. And we're starting to see the rise of things like counter space between large nations, parking assets close to each other and really starting to interfere with that infrastructure. And so if we can go to the next slide. We see huge explosion in the amount of infrastructure and investment, and we see significant risk of failure and issues along the way. And so this is a problem we're looking at as a company is how do we service, repair, upgrade, extend the life of this infrastructure to make it more cost effective and more sustainable. If we can go to the next slide. And so in future, we have no doubt that satellites will be serviced and protected on orbit. Trucks and planes and boats and every other sort of transportation and critical infrastructure, you don't build it, and if it fails, you turn it off and burn it up. So we are building vehicles to provide on-orbit call-out services, much like roadside assistance in space. And we're seeing both a dual-use civilian commercial application for this, but also a lot of this technology has distinct defence applications as well. Next slide, please. So the service we're developing with a number of commercial and government customers at the moment is called Orbit Site Assist. So we're building a space capability to go and build out these applications from last mile delivery in orbit, disposal of assets in orbit, inspection and monitoring of critical infrastructure, protection and control around critical infrastructure, and in future things like refueling, maintenance, repairing, all to make this whole ecosystem more sustainable and more safe for everyone involved. Next slide, please. And so key to that vision of what we're developing at the moment is a multi-role orbital servicing vehicle. The one we're currently building, and I'll move away from some PowerPoint renders soon to some pictures of actual spacecraft, is about 300 kilograms. It is building the capability to deploy payloads in orbit, host payloads, inspect other spacecraft, protect other spacecraft, a whole range of applications there, key of which is the high mobility of our engine and the reconfigurability of this to get it down to a price point that's acceptable to customers. Next slide. And so the key thing that we're very focused on and keeps me up in the morning and at night at the moment is our first rollout mission, which will be launching on SpaceX in early 2024. It is Australia's single largest operating satellite that's ever been built. It's about the size of a refrigerator, so it's pretty big. We've got a bunch of commercial and government customers on this mission. And it's really around tech demonstration, proving we can do this, getting to the rocket and launching early next year. Next slide, please. And a few happy snaps of our little baby at the moment. This is Optimus. You can see large solar panels on it. You can see the gold wrapping is what's called multi-layer insulation to keep everything cool inside when we're in full sun and warm inside when we're in the full shade behind the Earth's shadow. And so this is being built primarily in Botany in Sydney at the moment. It's a pretty cool spacecraft. And over on the right, you can see our separation ring that will separate us from the rocket and our propulsion there. And a bunch of our customers are hosted in these sort of black canisters you can see on the side there. But yeah, very cool. Very cool in what we're doing and sort of certainly Australian leading capability. Next slide, please. So I want to talk a little bit on the theme of today's presentation and completely agree with everything Sanjay said. What we get a lot from universities is we've got an idea, we've gone and patented it, and we'd like you to buy it from us for a crazy amount of money. That typically hasn't worked, certainly for us in the past, unless it's so cutting edge that it's nearly impossible to replicate. Some common approaches we see for success of moving ideas through commercialization pathways, particularly coming out of universities, is working with SMEs and primes. And I think Defence Trailblazer is a really good example of bringing those partners together to work collaboratively on projects to really drive some of those co-creation outcomes. In Australia, there's a lot of different grant programs from ARC to CRCs to commercialisation, some sector specifics. Certainly in the space sector, there's a number of Australian Space Agency grants. All universities have wonderful commercialisation officers. The beauty of them is connecting researchers to broader industry and government kind of network and sort of navigating those processes of agreements. And finally, private investors. We are a privately funded company in Australia. There's a number of different investor pathways, but it's often relatively hard to take an idea to investors without some sort of tangible prototyping on the way there. I'd say just a couple of key lessons. Cash flow and customers are everything. And in a startup, that's sort of where we live and die each day is to make sure we have money in the bank account to pay our staff and our suppliers, and that our customers are continually happy with what we're doing. Next slide, please. Little happy snap of our spacecraft inside a thermal vacuum chamber there. I want to touch on a few things that are quite unique to the defence domain. Defence, broadly speaking, is one customer. There are not many sectors where you have sort of one key customer driving the commercialisation process. And so just a few things we found and lessons learnt. We have a lot of interest and engagement from Defence. They are wonderful. Sometimes they love us too much. We've had many delegations of 10, 15, 20 people come from Defence, even though the whole company is, 20 to 30 people at the moment. So they love us. They love to seek feedback, consult, great at getting your input. But perhaps if I jump to point 3 there, contracts are hard. When you move from engaging with Defence to actually getting traction on a commercial perspective, that's a really hard process. And in Australia, we've got some uniqueness in the way we do it by typically putting globally open tenders that aren't necessarily focused on Australian industry, whereas certainly in a number of other Western countries, that's the opposite, where they're sort of focused opportunities for local industry to get involved in. So I can't emphasize enough the gulf between the interest and the engagement and the contracts, and that's where a lot of organisations fall down. Timeframes are something that will blow new players' minds in terms of engaging with defence. From first contacts to first contract can be a year, 2 years. There's a lot of reasons for that, which I won't go into, but it is a long journey. It's not one that in the commercial domain you can wrap up a deal within a few days, but in defence it's complicated. There's some overlay of things like export control, security clearances, and DISP. If you're unfamiliar with those in the commercial domain, it's really good to start understanding them. And there is some fantastic resources like the Office of Defence Industry Support that can really give you an overview of those resources and some of the complexities. Networking. So actually, speaking to Sanjay's point, finding the right people in defence is sort of key to your journey in defence. Talking to the people who are actually interested in what you're developing is fantastic. I can't recommend it enough. But defence often has a posting cycle such that once you've worked with someone for about a year or two, they typically change jobs. And as such, you need to constantly be aware of not just, one or two people, but what the organisational changes are within defence. And finally, something which I think dovetails into what Defence Trailblazer is doing, the Australian Strategic Capabilities Accelerator is standing up at the moment. And so that's one to watch for anyone who's looking at commercialising. They will be a key player in the next year or two, going forward for the next 5 years. But they're really standing up capability there. And my final takeaway is, if you can make it here in Australia, you'll probably be able to make it anywhere globally, because the budgets, the opportunity globally is more significant. But getting defence as that anchor customer is a bit of a stamp of approval to go global. Next slide, please. I guess there's also not one path to success. We're a space company trying to build space hardware. That's very different to an analytics company, which is different to someone who's focused on boots or uniforms or the many other requirements of defence. So keep talking to people, keep learning. There's a lot of people who are willing to help you along this journey. A personal reflection, ideas about 1% of the outcome, in my experience. Great ideas are fantastic. The ability to get something in a box on a truck with forklifts and regulations and approvals and all of that stuff is complicated. Managing people to deliver those outcomes is hard. And so if you're a university researcher, don't underestimate the challenge of bringing that idea into reality. That's where most companies kind of fail along the way. To Sanjay's point, it's going to be a roller coaster. It is incredibly hard. It is also incredibly amazing and well worth it for anyone who goes through it. Time is money. What's often lost in the way government and academia think is, if you have 10 people, you've got 10 staff and their salaries to worry about. And that's a constant need for cash flow and capital. And so when government programs move out 6 months, for particularly small to medium enterprise, that can be a significant burden on them to keep paying those kind of salaries. And that we've touched on, non-technology is sometimes the hardest. I guess in summary, takeaway point, there are many Australian success stories. Sanjay's touched on a few things like Jawn and Nolka, huge success stories. There's more to come, and I hope it's going to come from people on this call today. I think that's it from me.
Thanks, Mark. Great insight into the realities of running your own business in defence and the practicalities. That's very much appreciated. Our next speaker is Andrew Neely, Professor in Aerospace Engineering and Associate Dean for Research Engagement at UNSW Canberra. After graduating with a Master's in Engineering Science and a PhD in Hypersonics from the University of Queensland, Andrew spent almost 8 years at the University of Oxford in the Rolls-Royce funded OSNI Thermofluids Laboratory, eventually bridging the gas, turbine and hypersonic domains. He returned to Australia to join the growing hypersonics effort at UNSW Canberra, where he now leads a research group addressing structural and performance challenges for hypersonic vehicles. He's worked with many Australian and international collaborators on a wide range of projects. He's recently served as the Vice President of the International Society for Air-Breathing Engines and as the President of the Australian Division of the Royal Aeronautical Society. Over to you, Andrew.
Okay. So I guess just as some background, a bit like Sanjay, I guess my journey started as a typical academic, studied a mechanical engineering degree and then a research master's and a PhD in hypersonics at the University of Queensland. It wasn't really until I got into my fourth year project and the exciting opportunities at UQ at the time, and obviously there's still a great hypersonics group up there, get into this area that I hadn't, when I'd started in engineering, I wanted to be an aerospace engineer, but there didn't seem to be like a lot of opportunity when in fact there was. When I finished, I wanted to stay in hypersonics, but one of the best things that happened to me was that the opportunity became available over in Oxford to work in a Rolls-Royce funded lab over there on jet engines. Very different application, but very similar sort of technologies to hypersonics. Then turns out the environment inside a gas turbine and the materials and techniques used to study it numerically and experimentally are very similar to those on the outside of a hypersonic vehicle. And so I spent a long time over in there in Oxford, and I'll talk about that experience in a moment because it was very much bridging the gap, I guess, between industry and academia. And then since I've been back in Australia, I guess I've had a number of roles working with professional bodies with industry. So ISABI, the International Society for Air-Breathing Engines, is not your traditional sort of academic society. It's really an industry body, again, that bridges the gap between academia and industry. And so the president is usually a CTO of an engine OEM. Currently, it's the head of propulsion at Airbus is the president. And then similarly, the Royal the Royal Aeronautical Society in Australia, again, a professional body that sort of bridges between, I guess, practitioners and operators, airlines and Air Force and others, and academia. Having said that, I've maintained, I guess, my professional role as an academic, a research active academic. But part of my day job, not just in my own area of sort of aerospace, is as the Associate Dean for Research Engagement. So helping drive others to think about how they can engage with industry. And often when I talk about industry, I don't just mean commercial operations, I mean with government and other partners, sort of external to the university. So within the hypersonics group, we've done a large bunch of different projects with a bunch of different partners. Traditionally, though, these are government funded. So, the pots of money that a researcher traditionally still goes after in Australia, unlike other places like Oxford, where I'll talk about, is government money. And whether that's the Australian taxpayer or the US taxpayer, we've got a lot of our money to do, I guess, low to mid TRL level research and development on very much on applied problems often. But often, someone like the Australian Research Council, there is no customer. You just present an idea, and if you're lucky enough to win the competitive lottery, then you're up and running. Working with people like US Air Force through the AFOSR, for example, or HVSI, or directly with DSTG, then there's a customer, so to speak, and then you are not just getting money, but you're building a collaboration and you're working on applied problems. The relationship with industry is obviously starting to balloon, especially through opportunities like Trailblazer. And so having said that, though, even though these days I'm still very, our research here is still very much supported by government, I came out of, spending almost 8 years in the Rolls-Royce University Technology Centre in Oxford, at the University of Oxford. And these Rolls-Royce UTCs were, they were set up for a couple of reasons. I guess one of the key reasons was being in the aerospace industry, the financial model often isn't rosy and things swing between being good and bad. And Rolls-Royce was finding it hard to internally support a lot of its R&D. It wasn't able to keep people on to do that. And so they came up with this great idea of, why don't we solve that problem to some degree by doing our lower to mid TRL level research out in universities, but also then pick the best of the best, starting in the UK, with universities with expertise and specialist areas of need to the company. And that has grown. It's international now in some of their other markets around Europe and the US. And so the UTCs in Oxford, I worked in the biggest one, which was in heat transfer and aerodynamics, and there is another one in materials and structures, and there was a third one in control and sort of nascent sort of AI, that seems to have disappeared. So the OSNI lab, as it's known to those who have ever worked there or visited, basically, it's leading in the UK and Europe and the world in terms of some of its capabilities around, particularly in experiments, but also growing in simulation, and particularly in the people there, the researchers, around heat transfer and turbo machinery. Interestingly, it actually grew out many years ago, long before my time, from hypersonics. But Don Schultz, the professor, realized that there was no industry in hypersonics, but there was this industry in gas turbines that could benefit from some of the sort of the experimental techniques that they'd been developing in Oxford for hypersonics. So he cunningly pivoted to gas turbines and never looked back. Since then, I've been working over the last since I left a while ago to help them actually bring a lot of their hypersonics back online. So within the laboratory, they are benefiting from both of those ecosystems, given there's a lot of crosstalk. Now, even though we sort of talk about that lab traditionally being primarily funded by industry, in particular Rolls-Royce, of course, industry are very clever. What they're really doing is partnering with universities and going after often government money, whether that's UK government or European Commission, sort of Horizon 2020 style programs, large multi-billion-dollar programs across Europe that you can tap into in the partner countries. UK fell out of that funding scheme, but are now back in. Obviously, Brexit took them out, but they have managed to come back into it. So this lab, there were, again, everything from not so much really low TRL level, but mid TRL level and high TRL level, a lot of commercial outcomes for the benefit of the industry partner for Rolls-Royce, including technologies in particular for improving efficiencies of turbine blade cooling, and things like brush seals on board the engines. The problem is, though, this sort of collaboration model where it's particularly led by a single industry partner, you're prone to the financial success of that industry partner. And that laboratory has suffered the last few years due to COVID and the downturn of the industry, that Rolls-Royce services, particularly because Rolls-Royce had cleverly at the time set up rather than sell engines, they were leasing engines to airlines. And so they were having an arrangement called power by the hour. But that means that the airlines aren't flying, then you don't have an income. Now, Oxford, when I was there in this laboratory, it wasn't really known for spinouts. Lots of clever stuff, lots of clever people. But, since I left and since, I regularly visit and stay in touch, there've been a large number of spinouts, some gas turbine related, some more widely, things like solar thermal and heat transfer related, and flow related. And so that really is becoming part of the ethos, I guess, certainly in the University of Oxford. University of Cambridge is a little bit ahead of them, I think, in that game, but Oxford's really picked its game up. So the sorts of things I was contracted to do in the lab was they were on applied problems, helping come up with new techniques, I guess, to help design and test engine components. I spent a lot of time working with initially working with the folks in Bristol on II signature suppression. So this was dual use technology. Of particular interest to Rolls-Royce for defense applications. One of the challenges for academia in this game is you often find it hard to publish on things that are of particularly sensitive nature. And so you will not find any of this work published by me in the open literature. Well, actually, you will find the work, but you'll find no mention of helicopters and no mention of IR signature suppression. It just talks about fundamental heat transfer. But that work was very much supporting work within the company around how to improve the exhaust suppression, IR suppression on exhaust for helicopters. I then did a lot of work with the main part of Rolls-Royce. So Rolls-Royce, the two main sites are in Bristol, which is mostly defence technologies, and in Derby, which is more the sort of larger civilian engines. Though, of course, there's a huge amount of crosstalk between the two sites. Worked on technologies like fire certification. In fact, my single patent as an academic was with Rolls-Royce on a new technique for improving the fidelity of and reducing the cost of fire certification testing that is required by companies like Rolls-Royce for their components on the engines. The way Rolls-Royce worked at the time with academia is because Rolls-Royce was funding the research, I got paid £1 to be on the patent and never made any money from it. This patent wasn't really for Rolls-Royce to make money from, though. It was more to protect, I guess, the IP that had been developed. One of the spin-out companies that came later from Oxford actually did start to work in fire certification, though using some of these ideas. Interestingly, when I worked there, even though I had sort of 6 month, 1 year, two year long sort of research commitments on projects, I was also at the end of the phone. So anytime Rolls-Royce was having a particular issue, they could phone me or one of my sort of colleagues up and say, stop doing what you're doing. We have this problem on an engine now that's out in the fleets. Can you help fix it? We need to better understand, for example, the flow impingement on a particular component that seems to be overheating. And so one of the things I loved about this was as an academic, I had the freedom, I guess, to sort of generate ideas and help sort of define directions. But I was also working on very applied problems. It was continually, my thinking was being informed by need. In fact, every 6 months, every year, Rolls-Royce would offer me a position, but I'd say, no, thank you. I'm quite happy living the life that I'm living, because if I did go and work directly for Rolls-Royce, I'd end up probably in a design office, being far more compartmentalized than what I did. Oxford, given its geographic location, was also in the middle of a lot of Formula One teams, and so I got to do a lot of consulting in Formula One around various heat transfer designs, which again is very much driven by industry need for performance. Since returning to Australia, I guess a different collaboration model I've become involved in is the University Consortium for Applied Hypersonics, which was created out of the Office of the Under Secretary of Defense Research and Development in the US. They stood up something called JHTO, the Joint Hypersonic Transition Office, because they realized that they were no longer the world leaders in hypersonics for defense need. Really, their near peers in China and Russia had caught up with and in fact potentially surpassed US capabilities in some areas. But they knew that they'd been investing in, US government had been investing in US universities for, half a century in hypersonics or more, and yet they weren't seeing the transition into the hands of the warfighter. And so they stood up the JHTO, which then stood up UCA, the University Consortium for Applied Hypersonics, to try and drive academics together with industry partners to try and solve these problems. And so this is a very much government-led collaboration model out of the Department of Defense, out of the Pentagon. It's got about 113 universities now, of which, well, there are now 10 foreign universities. There were 5, UNSW being one of them, and a lot of industry partners. And so every project that gets stood up has a number of universities on board, and then has some industry partners and potentially research centres like Sandia on board. There are challenges in this, though, especially working with international partners. It's mostly American universities. Only American universities can lead. UK and Australian universities can participate, but there's been a lot of cold feet and backstepping around their level of comfort having these international universities being involved, particularly around information sharing that are still being worked through. So there are challenges. These are applied problems. We are working with American companies on one of the projects we're on, and again with US research labs. So let's take a step back and think about the big picture. As an academic, what do I think industry is looking for from academia when we talk about collaborative research? Well, they come to us for domain expertise, basically. We are experts in particular areas that we work in. But often it's not just that, it's bandwidth. And this is, I think, especially important for startups and scale-ups that just cannot afford to have the people on the ground to do some of their R&D. They can't have enough, they don't have the ability, the financial support to have a critical mass of a complete R&D team on board. So universities are a great place to come to do that. It gives them access to university facilities and infrastructure. And as you'll see, a lot of these attributes that I'm describing are exactly why the Defence Trailblazer exists. Industrial testing, where university does have facilities and people, we can do industrial testing, as I was doing in Oxford for Rolls-Royce. It also helps industry with the resources to perform our R&D, because it means they, as I said, we can go together, industry and academia can go together looking for the funding. Again, that's why Defence Trailblazer exists. It is leveraging the government's investment in that R&D. Access to ideas, because not all the best ideas come out of the industry partner. Some of those ideas can come out of the people in academia who work with them, and similarly then opportunities to commercialize that. And one key thing which often we don't think about but is obvious is access to future staff, because by working with the academics, but more particularly the postdocs and the research students that we're training, those are the people that can often end up in the industry partner. If we flip that over and say, well, what's in it for us? What are academics like myself, or like some of those online listening looking for? Well, I think the attraction is, it's all very good being a specialist researcher and locking yourself in your lab and publishing journal articles that no one ever reads, but really it's real world challenges and the opportunities for true impact. That's what helps me get me up in the morning is collaborating with practitioners and industry experts on problems of interest to them. I think Mark mentioned earlier that you might think that the outcome is going to be this, but actually even getting 20, 30, 50% of the way there can be useful, getting something that actually works, and often you find you end up in a different direction than the direction you started to come up with opportunities and solutions. More and more academics, I've personally not been very good at this, but I see this more and more, especially with my younger colleagues, opportunities to commercialize their IP, actually, step out either full-time or step out part-time from academia to become an industry person. I talked about industry wanting to come to us because of our resources and our infrastructure, and similarly for some industry partners, they have things that we can't afford or don't have, so it's very good to work with them. But there are these more traditional academic needs. We do need funding, we do need the ability to publish, but there are ways to do that. In fact, when I worked for Rolls-Royce in Oxford, it was actually often harder to publish the civil engine stuff than the defence related stuff, because they were even more sort of paranoid about security around their commercial IP, given that Rolls-Royce was making a lot more money out of civil engines than defence capabilities. Also access to future HDR students who are actually practitioners. And that brings me to this idea of the benefits of embedded higher degree research studies. I mean, traditionally universities are good at grabbing freshly minted graduates from undergraduate programs or master's studies, but these people don't have experience in industry. And so more and more we're trying to grow these significant opportunities around grabbing practicing professionals as part-time or even occasional full-time research students, because these practitioners bring their experience, their understanding, and their unique perspectives and challenges, so they don't just come to us with a problem, they come to us with ideas of how to solve those problems. It's good for them because they leave with deeper domain knowledge and practical solutions for themselves or their companies, their employers, opportunities to develop their own employers' IP. But we learn so much by having these professional research students with us. And for example, we currently have had students from Air Force, DSTG, Thales, US Air Force, CA, and even Royal Melbourne Hospital. I'm working, for example, with a surgeon on some stuff at the moment. So, the model that we're here today, really, I guess, to think about is the Defence Trailblazer model that drives together academia and industry, and Sanjay talked a bit about that at the beginning. An example of how we're doing that within the theme that I lead, the hypersonics and countermeasures, is, we're looking to build opportunities to collaborate with industry partners to develop and test their technologies in representative environments. And so we're looking at how we develop test beds on the ground, but also in flight, to actually do flight experiments for the benefit of onboard vehicle technologies, but also off-board technologies on the ground and in the air that can benefit from knowing that an object is going to be flying a particular trajectory. And so this brings together not just the theme that I'm helping lead, but also the space theme, the AI ML theme, and even potentially sometime in the future, the quantum and cyber themes. And I guess particularly one of the things we want to go after more in the Trailblazer, it's not just working with one company at a time. It's looking for opportunities like this that can add benefit to multiple industry partners, from existing mature sort of primes all the way down to scale-ups and, you know, 1 or 2 person startups that could benefit. They could never afford to do stuff like this by themselves, but they could certainly benefit from it and bring, I guess, opportunity for senior partners as well. And so that's, you know, to finish off then, you know, one of the new ways of working together that we've been sort of prototyping at UNSW, particularly in Canberra, is this thing called Launch, where we have a collaborative workspace in the city. It's been focused to begin with on cyber companies, bringing the cyber companies together to work with us, to work with our students. But actually one of the most significant benefits for them is being co-located physically. They learn from each other about technologies, but also about business expertise and how to go after government funding and things like that. And, you know, what university brings, as well as that domain expertise and the people and the students, is we carefully curate this innovation ecosystem, as we, you know, as DTB is doing as well. And we're going to scale this up massively as we're staying on the UNSW, we're staying on the Australian Defence Force campus in Canberra, but we're also building out on this new campus in the middle of town, the old TAFE campus, and we're going to build industry into that from the beginning. And as part of that, we're also looking at, you know, that's in the middle of town, a dedicated site for R&D collaboration to do experiments that we can bring in security. We can lock down these large-scale dedicated laboratory spaces, and so we're actually trying to build some partnerships at the moment, looking for partners to build this on the just across the border in New South Wales. And so this critically also brings co-location of people. So where we can really bring industry partners to spend significant time in the laboratory with us, working on their sensitive technologies and those that have government sensitivity. Okay, thank you very much. And at that point, I will stop sharing.
Thanks, Andrew. Your insights are incredibly valuable along a number of themes. Next up, we have David Hewish. David is the Head of Technology at Raytheon Australia, where he is responsible for the technology strategy, direction and solutions in the medium and long term. Working with the growth team, he is pivotal in proposing new and leading capability solutions for the defence customer. With 36 years' experience with Raytheon, David has worked across the organisation in various engineering and technology functions and projects, where his work interests include systems and enterprise architecture, complex systems, program execution and strategic planning. Thanks, David.
Thanks, Liz. And look, I think this will flow in quite nicely with Sanjay, Mark, and Andrew. I think it's been it'll be synchronised quite nicely. Look, Raytheon Australia is a prime. We're a system integrator. I'd like to give some insight into how we engage with the customer, and by customer I mean all facets of the Australian Defence Force, and some insight into what we're looking for when we do that, and then how we might engage and how we do engage with industry and academia, and then ultimately just in terms of partnerships, what are we looking for in a partnership? Next slide, please. Next slide. So some of this will probably be fairly obvious, but just to kind of set the scene, because I think it's an important thread through the whole process. So we clearly go through a process of looking at customer needs. We need to understand our customer, its overall needs. Sometimes there are operational concept documents, OCDs, sometimes concepts, sometimes scenarios. We have to work with the customer to work out what's important. And that's both in the technical world and the non-technical world. And I think Mark touched on some of those things as well. So in terms of the attributes and characteristics, we are looking at some high-level architectures. We're looking at the functions and performance, how it fits into defence, its interfaces, but also more broadly, how does it fit into defence people, the defence organisation, into the support structure and overall the timing of defence? And I think that'll be a theme that comes out through here as well. Customer usually has a contracting model. They have some constraints. They have what they call fundamental inputs to capabilities, so a lot more than just the technical system, all of which are important to defence in terms of capability. And of course, attributes beyond just the one-dimensional technical attributes include things like how do you overlay cyber? How do you overlay supply chain assurance? How do you overlay program risk on top of these things? So they become quite important. And again, from a customer point of view, when they engage with industry, they're looking for enterprise solutions, system capability needs. They're looking for architectures, function, and performance. And ultimately, as part of our process, we start to break that down into a system breakdown structure. From a business context point of view, the customer has a process in mind. They've got a timeline in mind. They might have multiple phases in mind for their capability. Sometimes they're well defined, sometimes they're not. From a Raytheon point of view, we're looking for viable solutions, feasible solutions, things that make sense to Raytheon in terms of our business. We have our own gate processes to go through, and that drives our level of interest and investment and partners and timing. And of course, that could be a multi-year process, as Mark mentioned. And of course, the customer engages through many different ways, right? Sometimes there are RFIs, sometimes there are experimentation phases, sometimes there's concepts that they consult on. Sometimes they're after options, and then ultimately they put out tenders for us to respond to. So, for both universities and SMEs or startups, there could be concept phases, prototype phases, demonstrations, a lot of investigation, and quite frankly, a lot of learning on everyone's behalf, including the primes. So from a primes point of view, we are looking for capability solutions. Typically, we're putting together lots of products, lots of components, subsystems, and of course, we're putting together a program and ultimately a capability. So it's the technical and the non-technical. That could be from 10 months to, say, 10 years. And say in the case of our guided weapons, it'll be a 10-year program. And so that back to Mark's point about cash flow and timing becomes quite important. But of course, we're looking for some kind of solution that's an advantage to the customer. We're looking at options. We're looking at trade studies. We're looking at the market. We're trying to find ultimately what's best, not just for Raytheon Australia, but what's best for the military. And our real focus as a theme is what's the best for customer outcome. That's always a guiding light for us. So in terms of the capability timeline, what is our strategy? How do we select university partners, SME partners, startup partners, who best meets the needs? And of course, the other part of that is we need to understand what the university wants or what the SME wants out of this, and that's not always obvious. And so we need to work in a real partnership to determine that. But ultimately, we're looking for a pathway to success, and that also includes, from a technical point of view, how do we integrate that into a capability and into defence? In the following page, I'll cover some examples, but we definitely need a plan for both a commercial and non-technical delivery, not just the technical, and that means everything up to including submitting a tender where we commit to something, and then all the work beyond that to actually make it happen. So this is probably the key chart for me, and so I'll spend a bit of time on this and give some examples. Looking at how, in terms of technology partner, how do we identify the partners? What are the attributes we're looking for? And what kind of relationship are we after? And I think this is fairly true for most primes. We may have a different flavour, but I think it's generally something that's all university and solution providers and SMEs should be thinking about. On the identification side of things, I think particularly for universities, primes need visibility. And I think it's kind of a key theme. I think Liz mentioned that. We tend to be fairly broad. We're deep in some areas, not deep in all areas, as Andrew mentioned, and we need the visibility. So there's probably a real clarion call there for how do the primes get the knowledge of what's out there, what research is being done, what knowledge is required to do it, and just getting the realization to do that. So I think there's a real, not just a pull, but from universities, there should be a real push into industry. We know some things, we don't know everything. And so that visibility and just being able to identify options and possibilities is really important. We're always looking for some kind of capability edge for the customer, and that, as Andrew said, often comes out of universities with really good ideas. And of course, the other thing not to assume is necessarily either the defence customer or a prime really understands all the potential benefits behind what you might be offering. And so sometimes while you're deep into the research, make sure the primes really understand the length and breadth of all the potential benefits of the technical aspect or the technology that you're proposing. For SMEs and for startups, it might be a bit more obvious because they're a bit more product focused and tangible. But I think that cohort also needs to push into the primes with knowledge and visibility. When we go into tenders, we're always looking for options for solutions. We need to know what's out there. So, my suggestion is engage with the primes and engage with all of them, but raise the visibility and make sure we can have the conversation in an ADF relevant way. So, we do need those options as we go into solutions. So we're looking for a good fit. We're looking for, does it meet the customer's needs? Are the concepts right? Is it best for customer? And of course, just pointing on the global suppliers there, we also push a lot of technology into our US suppliers. We have a global supply chain initiative. One example is the University of Adelaide had an iSafe laser we tried to put into our EO systems in the US. So there's always opportunities elsewhere, not just in a pure Australian ADF context. Looking at some of the attributes, finding things that are truly world-class. We don't need things that have been done before. So being able to identify world-class technology and technical research is really important. And we've got to validate that that's actually the case. We've had examples of some research that came out of a university that became a company called Poseidon. It was in the sapphire crystal area. Those sapphire crystal oscillators are now part of every Raytheon radar in the US. We've worked with another university on some neuromorphic event-based sensors. An absolute game changer for space-based sensing, which I think will be really prevalent going forward. These really are world-class ideas, and we need to get those things really clear and visible on the table. We're always looking for differentiators. I mean, defence wants a differentiator for defence capability, as does Raytheon or a prime. Is there a discriminator? Is there a military benefit to it? An example, we've worked with a company called Here Robotics on space domain awareness. Really novel way of actually doing space domain awareness that created a real differentiator. Solution fit, fairly obvious. Functions, interfaces, architecture, does it fit the overall design and the program? But technology maturity, TRLs, have already been discussed. That's not a problem. It just needs to be something where we work through where it's at, where it's going, what the program is, and overall readiness to move forward, readiness technically, readiness from a production process point of view, and readiness to apply to future programs. I'll touch on some business pathway later on, but I do think it's important that universities start getting into the game of looking about how do you convert this into some kind of commercial entity. Many ways to do that, and likewise SMEs need to think about how to then take their commercial entity to the next level. In terms of long-term feasibility, you were looking for, does the technology have long legs? Does the commercial entity have a good future? Will it scale up? Scale is important because we want long-term prospects and a long-term plan to get there. It could be that, if I ask the question, could you be a 30-year partner? They're the kind of things we're looking for. And there's a company called Micrio that we worked with many years ago for microwave integrated circuit. That's also now inside lots of radar warning receivers. It's been so successful that L3 Harris went off and bought the company a few years ago. Look, we've worked with another good example is we worked with a company that came out of university research called Amiro that did additive manufacturing. It's now listed on the ASX. We helped them with the compounds and the alloys. We helped them with mechanical properties and metallurgy. We helped them with trials. One of the big things we helped them with was their production techniques, and likewise introduce them into a wider market. So there's some really good examples of taking university initiatives and collaborations into a commercial entity, into a very successful outcome. Probably importantly on the right-hand side with relationship, we're looking for long-term partners, not so much after commodity items, but the right type of partner. Can we work together? Will we work together? And from a, if you like, a Wraith in Australia point of view, is there, does it fit our business applications and our plan going forward? Does it have the right breadth in the business model to go with that? Examples of that are some SMEs like Darrenmont and Aldom. They now produce these absolutely world-class and fantastic shelters that go into our deployed systems. They're now a long-term partner that really has a good business model. From alignment to customer capability, again, we're looking for partners that align to our customers' capabilities and where they're going. So that requires a good sense of what do you need now, what do you need in the future, what's that concept. From a technology maturity point of view, and I think this is especially true for universities, can we get to the right level of maturity? How do we get there? Can we get there? And by the way, who will get there? And what entity will do that? We've had some technology maturity things with things as companies like Enerquest. They had some existing generators to be used in the field. We had to make them defence ready. Simple things like how do you make them much quieter? It becomes a defence specific need. A really good story about how that's successful, and that business for them is just booming, which is fantastic. I'll talk a bit more about business evolution later on, but again, from a university point of view, how do we take the technical idea to a certain point in time at a certain phased plan with a certain maturity, and who will do that? From a Raytheon point of view, we like the idea, I use this term, bidirectional business enhancement or engagement. How do we work together? I think we've got to have this idea, and I think Andrew touched on it. How do we both, how does the prime learn, and how does the university or the SME learn? There's lots of bi-directional learning to happen there, and I think it's a kind of a key theme for me, how to do that, because we need to work together. How do we take the technology and put it into solutions? How do we inject the commercial know-how to make it successful? How do we apply, and again, I think Mark touched on this, how do we apply all the defence, I call it defence engineering. Defence engineering is different. Primes will need to help you with all that defence engineering knowledge between the system engineering and how defence works. It's very particular, and it's detailed. So how do we overall connect the customer's capability with the prime's need to respond and produce solutions, with the tenders that are required to do that, and a plan to get there for the technology? Defence also has a large sense of what I just call generally assurance type things. So how do we get the right assurance of the product over time to satisfy defence? So from a customer engagement point of view, can we work together to improve that visibility? Can we work out a great way to integrate it into the bigger picture solutions? How do we do demonstrations? How do we do trials with what resources? Is there an evolution plan? If it's not mature, can we develop an evolution plan to get it to the right level of maturity for the right time? And so we're going to work, let the prime and the technology innovators, how do we sell it to defence? Work together to sell it into defence. Next slide, please. So just coming at that from a kind of a different angle, and again, I think from a university point of view, quite rightly, the universities focus on fundamental research and low TRL, emerging technology, which is fantastic and where their space is. I would ask the question, however, at a certain point, and I think there is a role for universities to do this, how, and I think Trailblazer is exactly a mechanism to do that. At a certain point, how do we turn it into a business? And I know that sounds cold and hard, but it's got to turn into a business. It's got to be a viable business. And I think, working with the researchers and the technologists, there's also the commercial aspect of that about how do we turn it into a business. Looking at the top left-hand side there, we can look at the technology. Does it give us performance advantage? Can we see it as part of a capability? Those fundamental inputs to capability, they're also important. It's got to make sense there. There's no point having a technology that adds twice as many defence people needed to run the technology, for example. There are real-world, non-technical things we need to consider as we visualise the capability fit. From a technical and business fit point of view, does it fit into the defence evolution? Defence is going in a certain direction. Are we aware of that? Are we aware of the timelines attached to that and planning for it accordingly? If there's a particular program, it'll be a named program that defence is targeting. So expect the IIP to come up next year. And so the primes will be targeting those programs. So the technology that universities are developing How do we target those programs? And again, with a timeline in mind, but also, again, back to Mark's point, you've got to time your investments, time your cash flow, time your entry into the market. But we need a commercial plan. It needs to be viable, it needs to be feasible, and it needs to be a sustained plan, because defence is looking for long-term customers as well, not long-term suppliers as well. They can't have something unsupported in 2 years' time. They're long-term contracts. And of course, defence have a real sense of risk and assurance, and the primes need to work with universities to get to that point ultimately. At the bottom left, Raytheon itself, we want to make sure that those partnerships really are strategically aligned with what we're doing. So we take a portfolio view, can it hit across different portfolios, can it actually benefit more than one particular area and broaden its application? And of course, from a technical point of view, is there a technical pathway beyond the initial technology? We're looking for long-term futures. Obviously, we want the physics of the situation to work, but also we want the economics and the feasibility to work long-term as well. So on the bottom right-hand corner, we think the answer, which is, I think, a win-win for universities and for SMEs and startups, is long-term partnerships. Let's find that, to use that cliche, that win-win arrangement. Let's do the bi-directional learning so we can actually get a mutual benefit out of that. We also recognise the fact that, and this has been our history, we need to work with all the SMEs or the commercial entity to work out how to work with defence. Defence is tough. It's a detailed process. The timelines are long. It can be rewarding, but it is hard work. And so we find we always need to work with SMEs to make their life easier. At the same time, that educational process as to how to work with defence and defence process. So we're very keen to obviously help the universities and the SMEs get over those humps and get to a good, stable, commercial entity. So in the end, we think long-term partnerships for all those reasons are the way to go. Next slide, please. So this is the last one. So just going from the left-hand side, let's in a mutual way convince ourselves we are really working with world-class technology, and it really provides advantage to the customer and overall, the breadth of the ADF. But let's also make it visible. Let's really get it out there and make sure these things are visible and the options are on the table for all the potential providers to give to the ADF. I'd also go back to, there are lots of opportunities overseas. The primes can provide those avenues through what Raytheon calls the global supply chain, like that Poseidon oscillator I talked about. If it's world class, you might have markets elsewhere, and we can help with that part of it as well. Looking at the top left, the maturation timeline. For universities and technologies, there will be different timelines. We accept that, and it's a matter of how do we work with them. What is the evolution path? Can we do our best to predict the way forward on the research and its conversion into capability? What program and capability are we targeting? Let's do that together. And can it be integrated into defence? The top message, that commercial plan, is probably the key message for universities. Alongside the technology, we have to have a plan to commercialise it. And maybe we don't know that on day one, but we need to get there at some point. Don't leave it too late. So what is the business model? Is it a spin out from a university? Is it an SME who might pick it up? Is it a joint venture of some sort? But I would add to the point, for defence, we have to plan for a military product, not just a commercial product. And that's a massive overlay on what might be, say, for a telco. There are different levels of reliability and sustainability and military context we need to deal with, and of course the military process that we have to live by. So we need to sell that as a strategic benefit, but also invest in that process. I've discussed that idea of bi-directional collaboration to help. The primes, bluntly, primes learn a lot from universities and SMEs, as Andrew said. But likewise, I think any emerging commercial company, if they want to work in defence area, use the primes, work with us. Raytheon's certainly keen to do so. How do we help get you guys defence ready, if I use that term? So let's plan the science. Let's plan the science to go to a product, the product into a system, and the system into a capability. So let's help navigate that. Let's help that with the defence process. And I'd very much emphasise, and again, I think Mark might have said it, the non-technical aspects really are as much of the challenge as the technical. So for Raytheon, what are we looking for? Those long-term strategic partnerships, and very particular partnerships that meet all those criteria that I talked about, but also strategic for defence, differentiators for defence, things that make a difference to military outcomes, but also I use the term good meld. It's that idea of between all the playing partners. Let's make sure it's a good meld to work together, and that takes time to establish that relationship. And in doing so, we'll actually end up having a good long-term partnership. And then ultimately, I think that leads to making technologies, universities, startups, SMEs successful. Thank you.
Thanks, David. We appreciate the practical approach to engaging with innovators. I'm sure you'll be very popular in the follow-ups. On that note, a reminder to put your questions in the Q&A function. Our final guest speaker for today, before you hear from me, is Francois Duvenage. Francois is the Director of Commercialisation at the University of Adelaide. His expertise in technology transfer, commercial law and intellectual property has laid the foundation for his current role, where his primary focus is on educating researchers in commercialisation, managing strategic investor relationships, negotiating licensing deals, and the establishment of spin-out companies across the university. Over to you, Francois.
Hi, good day, everyone. Thanks for the intro, Liz. So Liz has asked me to just share a couple of slides around the pathways for commercialization, and specifically how the University of Adelaide support researchers. But I think it's most probably general in a certain sense for the way that UNSW is doing it as well. So the slides are quite wordy. Normally I don't have those types of slides, but considering that we will share these afterwards, I thought that, having enough information in those so that you can go and reread it, or if you want to share it on to your colleagues, at least there's, substantial information and not just a couple of pictures. So next slide. So just quickly in terms of the background, commercialization is a key activity, not just for the university, but obviously in the Defence Trailblazer. And that's one of the mechanisms and one of the key ways that we can generate impact from research, and how we can translate this into real benefits for society, and obviously generating income, but also creating jobs for the future, not just for the people that is currently working in Trailblazer, but for those students that is coming through the university, and then obviously the secondary and high school kids that wants to go into this space as well. The commercialization office, as otherwise known technology transfer offices, and again, not just specifically to the University of Adelaide, but other universities as well, normally support the researchers in establishing spin-out companies. We support them with achieving and sustaining growth, and we've got different mechanisms in terms of how we support these activities. But obviously, there's also those opportunities where we do not necessarily create a spin-out company, where we've got an established technology, and then we proceed to license that technology into established companies that has a core service or business offering already. Next slide. So why does it matter? I think we've heard a lot about where Australia currently sits in terms of the research investment that we're getting, and how much of that is actually converted into commercialization activities. And also where we are ranking in terms of research spend, but then pure commercialization activities within the wider ecosystem. So the universities, as investors of IP and other resources, like I said, would normally negotiate royalties, or we will make a direct investment, or convert the IP into a value, and we will then convert that into equity or an indirect equity, where SAFE notes or convertible notes are issued to the university. In the University of Adelaide, we've got a equity holding company, ICP Pty Limited, and most of our shares are being held in the equity holding company that's got its own board, which means that if there's decisions that needs to be made, documentation that needs to be signed, relying on short turnaround times and not beholden to waiting for the university council to meet 2 or 3 or 4 times a year, we are capable then to turn around those quick decision-making opportunities so that we can be commercially responsive to the needs of the spin-out companies. I think important that commercialization offices as a norm sits within the university. It's a professional service that the university provides to the researchers, and most of the time it comes free of charge, unless like we make a direct investment either through IP or investment funds. Next slide. So in terms of commercialization support, the main areas that we provide support around is licensing, company formation and business planning, accessing university resources and infrastructure, IP management, building the team and funding. And as I go through the next couple of points, instead of purely talking about what's standing in the slides, I'll see if I can just put a number of use cases around how we've supported companies and licensing opportunities with industry partners. In terms of the merger that everyone obviously is aware of between UniSA and University of Adelaide, legislation has been passed. It's bound to be promulgated within the next couple of weeks. So I think it's worthwhile just mentioning that as it stands, a lot of the student support is being given by ThinkLab that sits within the University of Adelaide. It's the oldest accelerator incubator in Australia. And then obviously with the merger of UniSA, they've got another unit that supports external companies as well. And obviously the commercialization officers support the researchers. So I think with the merger, we actually set quite well to support all of the activities, right through from researchers, external businesses associated with the universities, and also students. Next slide. So, I mean, the stock standard way that we do commercialization is obviously through licensing. We identify a specific piece of university IP, and that might be, something in formal protection like patents, but it also might be just something like software, which is both protected by copyright or trade secrets. That specific combination of gases that you use to produce hydrogen or whatever the case might be, or the formulation for photocatalyst material. All of that can be commercialized. And if there's an embedded industry partner or an industry partner that already offers this type of service, we will normally work with them and we will negotiate the commercial licenses with the companies. And under the university's IP policy, and again, similar to UNSW as well, there is beneficial sharing back to the inventors of the IP. In terms of company formation and business planning, it depends on how the company gets formed. We sometimes work with educated and highly skilled entrepreneurs that come to the university and they have identified a piece of IP or they've discussed an opportunity with a researcher, and they decide that they want to commercialize the IP, they want to go and raise investment. They will then move forward, they will establish the companies, and the university will either just give a license to the IP, or we will work with the investor group and take up an equity position in the company. But there's also certain instances where we get hands-on, literally get our hands dirty, where we sit with the researchers go on the ASIC website, register the ABN, the ACN, support them with establishing a website, do the ATO registration, support them with a MyOp or Xero accounting platform, so that they can actually code all of the transactions that's going through it. So it just depends on, what type of support the researcher requires. We have found in the past that if there's a management team around the researcher founders, it supports them a lot. 9 out of 10 times, they see themselves as chief technology officers, not necessarily CEOs or, chief commercial officers. So, we can fulfill a certain amount of those activities. And then obviously with our networks, which is not your stock standard industry networks, it's high net worth individuals, family offices, and we support them, making sure that we introduce them to accountants that is used to working with small, medium enterprises, startup companies, accountants, lawyers that have done, employee share option plans in the past. So again, surrounding them with the right skill set and not necessarily handing them over to a KPMG or, Ernst & Young that will charge them an arm and a leg to perform some of these services. Next slide. And then again, accessing university resources and infrastructure. I think one of the things that we've realized over the last couple of years is that we've got about 18 companies that are associated with the University of Adelaide that has been established since 2016. 11 of them were incubated within the university. That means that we've gone back into the faculties, the head of schools. We've negotiated preferential terms for them to accessing labs or office space or lecturing resources. So if they need to do marketing activities, from those 11 companies, all of them have gone on and have raised either seed funding or Series A by now. The other 6-7 companies that did not get involved within the university and to a certain extent didn't want the university to support them and were not supported through incubation, those 6-7 companies are still struggling along. So there's a huge amount of benefit for the university to support these startup companies in the early days. And that allows them to actually use the money that they raise to develop and further mature the technology as opposed to spending on office space. And, it doesn't really add any value in those early days to the company. So it's definitely, like I said, a big benefit being associated with the university. And obviously also using the university's resources and networks insofar as marketing, being invited to investor forums and all those type of things. And then obviously IP management. When we license IP or when we make it available to a spin-out company, again, we are mindful that, the researcher founders doesn't always have the skill set to be able to manage these patents. We've got a registered IP attorney within our commercialization team, and he would normally support them, making sure that we, act on, the office actions, play a role between the patent attorneys and the licensee of the technology. Again, making sure that we've got the right protection strategies in place, making sure if there's trademarks that needs to be registered and all those type of things. And again, that cost is being borne by the university, not necessarily by the company. Again, which they can then use that savings to further invest and de-risk the technology that they're working on and get it to market, obviously at a lower cost and in a speedier way. Next slide. Also, looking at building the team, I've just gone through a process now where we've established a company, a researcher, founder, sole director of the company. We've made certain introductions, instead of appointing more people to the board, because obviously there's a certain amount of risk involved for directors joining a startup company. We support them by establishing an advisory board, making sure that they get the right people into those positions. And again, advisory boards normally provide that type of service free of charge, and support the early stages of the company. With the company that we founded in the beginning of the year, over the last 9 months, we've established an advisory board. Plus, we are interviewing for an interim CEO, and that's a person that has already established 1 or 2 companies, have been quite successful, have sold out on a couple of those companies, and is looking to reinvest back now into the next startup company that is coming through the university. So again, we're using our networks and advisors and service providers to support these companies, to make sure that they can move ahead without being left out by themselves to battle all of these different external things that they get against. And then again, with funding as well, our networks is different than what we will find with normal business development or people that support research services. Within ICS commercialization, we've got 2 funding streams. The one is the Commercialization Accelerator Scheme, which is about $1 million per year. And we use that to further develop the commercialization readiness level of a technology. So we don't fund fundamental research. It needs to be something that will move us ahead as quickly as possible, so we don't need to wait for 12 months to get a ARC linkage agreement in place. And then we've got the ICP Commercialization Fund, which is the $5 million fund. And we can use that to make seed investments, so for the establishment of a company, or we can use that to make a follow-on investment as well. So again, we are set quite well in terms of supporting a lot of these types of commercialization activities, while we are taking that fundamental research, putting it through the translational research and development. And I always talk about the small R and the big D. We focus on the big D, not the small R. The research is being done by the university, and there's sufficient other funding streams to fund that fundamental research. Our big focus is on the big D, making sure that the development stage happens and that we can take it out of the university and facilitate that transfer between research and industry. Next slide. Yep. And 1 minute over. Sorry, Liz.
Okay, Francois, I think there was a bit of pressure on you at the end. Thank you to you and all our guest speakers. We're very grateful that you could share your experiences and provide insight into the options that are available when we're considering commercialising our innovations. Next up, I'll present on the innovation programs on offer through the Defence Trailblazer and our partners. Next slide, please. The entrepreneurship and commercialisation activities are at the core of the Defence Trailblazer innovation portfolio. The activities will include a boot camp, validation days, entrepreneurial foundations for defence program, and bespoke incubation support. There are 3 key areas of focus for the programs: product and technical development, entrepreneurial skills and business fundamentals, and defence readiness. Next slide. We have our Innovation for Defence boot camps coming up in late February, in person in Adelaide, Sydney, and an online option. There will be a 2-day commitment. I really liked your words, David, and I think it underlies the boot camp: conversations in an ADF relevant way. The purpose of the boot camp will be to help you refine your value propositions for defence, introduce you to the foundations of entrepreneurship, test the technical feasibility of your ideas, and identify the potential commercialisation pathways that might suit you best, and the next step to achieving those pathways. Applications are open on our website. Next slide. We'll also undertake validation activities throughout the year, initially to test and validate your idea and its application to a defence problem. We'll check in with the experts, IP, competitive position, commercialisation pathways. We'll check in with the technical experts, like pathway and timeframe to commercialisation. And through the seed funding program, we will present the most competitive ideas to some of Defence's relevant domain experts and seek their feedback. Next slide. Our Entrepreneurial Foundations for Defence program will have 20 participants over 10 weeks, delivered through online seminars, mentoring and expert coaching in areas of need. Each team will be allocated a mentor to support you through this journey. Next slide. From the Entrepreneurial Foundations program, we will commence a bespoke incubation program. These incubation programs will be in 90-day cycles. Every piece of technology has a different journey into defence. And the idea of this program is to design individual support for each team. The objectives remain technical progress, business sustainability, and defence readiness. We will also start to consider and define appropriate procurement pathways into defence. Next slide. There are also a number of supporting programs, including the ProtoLab network, run by our ProtoLab network manager. We'll provide a platform and act as a concierge for facilities, equipment and capabilities across our partner universities, our partners and our delivery partners. The objective of this program is to provide technical expertise and resources to support prototyping, test and evaluation and low-scale manufacturing. Sure, this one will be of interest to many. Our next supporting program is the Seed Funding Program. The program has two main streams, the Seed Innovation Fund offering 2 annual competitive grant rounds. The first one being $50,000 for prototyping technical development applications, and that'll open in May. The second, a larger round, $150,000 for commercialisation activities, and I often use Francois' line of small r, big D. May include technical development, business development, or defence readiness needs like DISP. Applications for that will open around August. There'll be a competitive selection process of sovereign innovations around the following criteria: defence validation and defence readiness, commercialisation timeline, technical feasibility, IP position, and the founder's profile. The selection will be determined by a revolving panel, including defence, industry, and technical experts. The second piece of the seed funding program will be the Investor Access Panel. It's a group of active investors with an appetite for defence technologies, from angel investors to those looking to support Series A and Series B raises. We will offer individual introductions where appropriate and facilitate pitch events throughout the year. Concurrent to the programs we're offering, there are a number of complementary programs run by our university partners and others supporting defence innovation and industry. ThinkLab, run out of the University of Adelaide, is offering a number of programs that may be relevant to those on the call. ThinkSeed for Adelaide CBD businesses looking to raise seed capital, e-challenge activities starting in February, and Think Boards for startups looking to establish effective boards. We will also support the Defence 10X Accelerator program with grant funding, technical and defence readiness support, delivered by the founders team at the University of New South Wales. Applications for that will open in April 2024. The founders team will run a number of pre-acceleration programs through May, expressions of interest are open for both the pre-accelerator and the accelerator, with the expression of interest form found on the founder's website. For those in Canberra, check out the Canberra Innovation Network. They have a number of research, translation and entrepreneurship support programs to support your innovation journey. I think Mark mentioned it early on. The Office of Defence Industry Support, or ODIS, has been established to provide advisory guidance and mentoring services to small and medium enterprises in Australia. A great place to start is their Defence Business Readiness tool, which can be found on the ODIS website. And last but by no means least is the Australian Strategic Capability Accelerator, or ASCA, which is of course of interest to all of us working in defence innovation. The ASCA team has their information sessions over this week and next. Please head over to their website to find the relevant sessions in your state. I think we have a little bit of time for some questions. The first question was, how transparent are the processes for funding selection? Just checking in, was that directed at Francois or for Trailblazer, I guess? Are you there, Francois? Would you like to answer that one? Or we can direct it to you later.
Sorry, you just broke up there, Liz.
The question is, how transparent are the process and the funding schemes?
It depends. For the commercial accelerator scheme, we normally work with one of the commercialization managers. So it's a project that needs to be supported by a commercialization manager. We look favorable on projects that already has an industry partner associated, and that can be an end user, meaning someone that can validate the technology, or it might be a commercialization partner, someone that is actually looking to license the technology. And there's certain activities that we will fund. We don't just pay salaries. There needs to be a tangible outcome. So we need to see how the technology is being de-risked through some of those activities. And then for the investment from our investment fund, that's a formal process, as you would essentially apply for any or make a pitch for any investment fund. And we normally require that there's also a third-party investor involved, which to a certain extent shows that it's not just the university that thinks that it's a good investment. There's third-party investors that is willing to put their cash in and share the risk.
Great. And there's a follow-up question for you. Is the ICS commercialisation support model for Uni SA and University of Adelaide, or is it a commercial service provider available for other Australian universities?
As it stands at the moment, it's limited to researchers that's employed by the two universities. I know that in the past there has been a couple of commercialization offices like UniQuest that in the past have acted as the technology transfer office for other universities. But as far as I'm aware, most of the universities in Australia do have access to some commercialization support within their universities. Obviously, in those instances where there's researchers that works with the University of Adelaide or UNSW, then we can always have a discussion around who will take the commercialization lead, and that will assist with getting access to these commercialization resources.
Thank you. Another question. The Trailblazer website priority areas don't include medtech innovations. Will you consider medtech innovations? Our Trailblazer entrepreneurship and innovation programs are not restricted to the priority areas identified for other parts of Trailblazer. Appropriate medtech innovations will certainly be considered. Fundamental to any choice we make around innovations is an improvement on the current state in defence and the identification of the problem that you're solving within defence. I hope that answers your question. Any other questions? Thank you all for joining us today. We look forward to working with you, and hopefully you'll join in on our boot camps in February. The applications are open and we'll send that link through over the next couple of days. Please also feel free to follow us on socials, Defence Trailblazer Facebook and LinkedIn.